Today we're exploring exponents and exponent rules. So the first thing we need to understand is the difference between a term of degree 1 and a term of degree 2. So we'll start by looking at the characteristics of degree 1 terms, and that is what you can see right here at the top of the screen. So these are situations where the exponent is a value of 1. You can see here that the variable x has a 1 in its exponent, or you can write it without an exponent, because to the exponent 1 is the same as just x. It is also really important to note that a single variable term of degree 1 represents length, which is in one-dimensional space. So it's in one-dimensional space. Now moving on to single variable terms with degree of 2. So it's important to remember that these are any exponents you see that are raised to the power of 2. And these types of variables represent area because they're in two-dimensional space. I now want you to take a moment and just think. So if single variable degree 1 terms represent length, and if single variable degrees of 2 represent area, what do you think single variable terms of degree 3 would represent? So we're looking at anything that would look like this, x to the 3. Hopefully you were able to come up with volume, because that is correct. Any single variable term of degree 3 represents volume and is in 3D space. Hopefully you can see the pattern that is going on here. The final section of this lesson deals with exponent laws. So we're going to start with a definition. Powers, a synthetic method used to express repeated multiplication of a number called a base. The number of times the base is multiplied by itself is called the exponent. So the two most important concepts of powers from this definition to remember are that you are always using multiplication and the number you are multiplying is always the base. So the value of the base times the value of the base times the value of the base again and again, and you repeat that for as many times as the exponent tells you to multiply. The two most important concepts of powers to remember from this definition are that you are always using multiplication and the number you are multiplying is always the base. So the value of the base times the value of the base again and again, and you repeat it for as many times as the exponent tells you to. So we have an example right here. So this is read as such, 3 to the power of 5, okay? So first we have to identify what the base is and what the exponent is. So 3 represents our base, and 5 represents our exponent. So if we were asked to evaluate this power, we would do it as such. So 3 to the 5 is equal to, by definition we use repeated multiplication of the base, 3 times 3 times 3 times 3 times 3. So you can see we followed this definition exactly. We repeated the multiplication of the base, which is 3, for the amount of times told in the exponent, so 5 times. So we did 3 times itself 5 times, which then gives us the value of 81 as our final answer. So just to label this so that you guys know what we're dealing with, this is our power form. This is our expanded form. And this is our evaluated form. Or otherwise known as our final answer. Let's now work through one more example. So this example here on the sheet is read as negative 2 to the exponent 3. So we're going to multiply our base by itself 3 times. So it's going to be negative 2 times negative 2 times -2, and then we go about the multiplication, and that gives us -8. And that's the end of our first lesson for exponents and exponent rules.